Welcome everyone to our plane majoration series, the SSC aspect of it. Today we'll be treating parallelogram. A simple diagram of parallelogram is given below. Area of a parallelogram is equals to B times H, which is the same thing as base times height. And applying the given angle there is the same thing as AB sine theta. Next, we take examples. 2007, 34, NECO. JKLM is a parallelogram and MN is perpendicular to JK. Next, if JM is equals to 13 cm, MN is equals to 5 cm, NK is equals to 10 cm, find the area of the parallelogram. Solution. Area of a parallelogram is equals to base times height. The base here is JK. NK is given. JN can be gotten from Pythagoras rule in the right-angled triangle. Thus, 13 square will be equals to 5 square plus JN square. And the result is 169 equals to 25 plus JN square. Making JN square the subject formula, we have 169 minus 25 will be equals to JN square. The result is 144 equals to JN square. And that will give us square root of 144 equals to Jn. That's to say Jn is equals to 12 cm. Then we can proceed to the area of the parallelogram properly, which is equals to bracket open 12 plus 10 bracket close times 5. Because area of a parallelogram is base times height. The base now, from our calculation, we have gotten 12, which is our Jn, plus NK. NK there is 10 cm. Hence the presentation. And the result will be 22 times 5, which is equals to 110 cm squared. Another example, 2014/13 NAPTEP. The diagram of the parallelogram is given. Next, we have ABCD is a parallelogram of height 6 cm. Angle ADC is equals to 30 degrees. And distance AB is equals to 70 cm. Calculate the perimeter. The options are given. Solution. Perimeter is equals to distance around a particular shape. Here, AB is equals to DC, which is equals to 70 centimeters. Opposite side of a parallelogram. They are equal. Similarly, BC is equals to AD. The same reason. Opposite side of a parallelogram. They are equal. From the given problem, AD is not known, but we can solve for AD in the right angle triangle by trig ratio. Sine 30 degree is equals to 6 over AD. And we know the result of sine 30 degree is 1 over 2. By trig ratio, sine 30 degree is half. And when you cross multiply it, it will be half AD will be equals to 6. And that is the same as AD equals to 12 cm. Thus, perimeter of the parallelogram will be equals to the distance around the shape, which is 12 plus 17 plus 12 plus 17, and that is equals to 58 cm. Another example, 2011/47 NECO. In the diagram above, determine the area of the parallelogram. The options are given. Solution. Area of parallelogram is equals to AB sine theta. Here, our AB is 6 times 8 times sine 45 degree. And by trig ratio, sine 45 degree is the same thing as 1 over square root of 2, which is 6 times 8 times 1 over square root of 2. Rationalizing the sort, it will be 6 times 8 times square root of 2 over 2. And the result is 24 root 2 cm squared. Another example, 2008/9 NAPTEP, November. The perimeter of a parallelogram is 38 cm. If one of the sides is 12 cm, find the other side. The options are given. Solution. Perimeter is equals to distance around a shape. Note that the opposite sides of a parallelogram are equal. Hence, with the one given side, we can sketch the parallelogram as given below. Next, we can substitute for the perimeter, which is equals to distance around the shape, as 38 equals to 12 plus 12 plus 2L, where the 2L is the sum of the two other opposite sides. And that will give us 38 minus 24 will be equals to 2L. That will give us 14 over 2 equals to L. Thus, L will be equals to 7 cm. Next, we treat properties of triangles and parallelograms on the same base and between the same parallels. 1. Triangles on the same base and between the same parallels are equal in area, as shown in the diagram below. In this, we can conclusively say area of triangle ACD is equals to area of triangle BCD. 2. If a triangle and a parallelogram are on the same base and between the same parallels, the area of the triangle is equal to half of that of the parallelogram. From the diagram, we can deduce area of triangle ECD is equals to half of area of parallelogram ABCD. The third postulation. Parallelogram on the same base and between the same parallels are equal in area. From the given diagram, parallelogram ABCD and PQCD are on the same base DC and between the same parallels AQ and DC. Thus, parallelogram ABCD is equals to parallelogram PQCD. Next, we take some examples. 2006/11. In the diagram, PQUV, PQTU, QRTU, and QRST are parallelograms. Distance UV is equals to 4.8 cm, and the perpendicular distance between PR and VS is 5 cm. Calculate the area of the quadrilateral PRSV with the diagram shown below, and the options are given. Solution. Area of quadrilateral PRSV is equals to area of parallelogram PQUV plus area of parallelogram QRUT plus area of triangle RTS. Recall that parallelogram between the same base and between the same parallel are equal in area, and half area of parallelogram is equal to area of triangle between the same base and same parallel. Thus, area of parallelogram is equals to base times height, which is equals to 4.8 times 5, and that is 24 cm squared. Now, area of triangle, which is equals to half area of parallelogram, which is equals to half times 24, and that is equals to 12 cm squared. Thus, area of quadrilateral PRSV will be equals to 24 plus 24 plus 12, and that is equals to 60 cm squared. Another example. 2006, 35 NECO, December. We have a diagram given there. In the diagram above, TUXY and ZVXY are parallelograms. If the distance TU is equals to 13.5 cm and the area of parallelogram ZVXY is 67.5 cm squared, calculate its height. The options are given. Solution. Parallelogram between the same base and the same parallel are equal in area. Thus, ZVXY is equals to TUXY. And area of parallelogram TUXY is equals to base times height. Note that YX is the same as TU, opposite side of a parallelogram. That's the reason. So, substituting for the given value, for area of parallelogram TUXY equals to base times height, we have 67.5 equals to 13.5 times h. And that will give us 67.5 divided by 13.5 equals to h. Thus, h is equals to 5 cm. We've come to the end of the examples on the parallelogram. Next, we have some exercises at page 343 and 344 of the hidden fact in new SSC mathematics. Try your hands on the exercises. The answers are given at the answer section of the book. The hard copy are available in the bookshop. If you wish to have access to the soft copy, our website is given at the bottom of the screen. Thank you.